All right, now we're going to really get into the schematics or the wiring of this unit. This is the pictorial schematic, so it gets a little wild, and I'll do a little thing here and there just to make it more proper in my mind, that I will not judge you if you should fail to do. But the first thing that we're going to do is all of L1's power is coming through that door switch. This is a switch that is on the blower door of the furnace. It is the first safety. It is the most wired around and done away with safety that there is. And I want to encourage you guys to refuse to do that. To always make sure you've got both kinds of door switches on your van. They only cost a few dollars, and you can keep units safe. Yes, you know to keep your hand out of the blower when it's moving. Hopefully the homeowner or the tenant knows to keep their hand out of the blower when it's moving. 5-year-olds do not. Cats do not. So it is a door switch. I mean, it is a safety switch that is there for a purpose. I know technicians get fed up with door switches. I understand entirely. There are products to help you with that frustration to actually clip it closed, but you might find it's just easier to carry tape or a variety of other things. Maybe you're just going to carry an alligator clip, but don't lose your alligator clip and leave that door switch, energized. Now I'm going to do this one little funny thing just to keep it proper, in my mind anyhow. I'm going to energize that side of the transformer, and then I'm going to come down here and go to the other side. So that establishes 24 volts control power. And the reason I did that is because I don't want to cross my neutral line with this. Most important part of the 24 volts is connecting up to the thermostat that orchestrates the whole thing. I've also got a power connection that I need to do for 120 volts over here at the blower relay, which really in most furnaces, the only 120 volt thing in there, domestic furnace, will be your blower. Air handlers for a heat pump system or maybe a hydronic system may well have a 230 volt blower, but it will still be the single high voltage thing in the cabinet. Now, who can tell me on the thermostat assignments what green is for?
Brown.
Hmm?
You said brown.
G, or the G terminal on the thermostat.
Hello.
Green is always identified with green.
I drive a Yukon.
Always?
Is it different in heating in there?
Huh?
You out there?
I said, as far as I know, it's always been green.
Electrically, you're right.
Yes.
You think of it as a ground thing. In this instance with the thermostat, G is always fan.
Always fan.
Always fan. So what I'm going to do with G is I'm going to come down here and energize my blower relay. After which I am going to go back to the common side of my thermos or my transformer, making my first complete control circuit.
I'll ask my questions after that's done.
Okay, we can do that. We might even make a third questions video. All right, so now we have our blower relay tied in with G off the thermostat. Y is for cooling.
Mhm.
So we can take our Y and go to our control contactor. That's what's going to control cooling. Now before we do this, we're going to go through our high pressure switch. Our high pressure switch, if the pressure gets too high, if no one ever cleans the coil, if the condenser fan stops working, the pressure switch there is going to prevent damage to our compressor. So through the pressure switch and take it the rest of the way to the cooling contactor, and then we can bring it back to common, because after all, we've got to have two wires for a complete circuit. Now, you can stop here and just connect it to right there, or you can take it all the way back. Just say maybe there's a terminal block there. Now, W is always for heat, but this is not a heating class, is it?
Nope.
Nope. There's another schematic for heat. We'll go through it. And really, I don't have room. Sometimes in the heat schematic, I'll just, scab on a air conditioning or a little fan thing or something, but I just don't have room on this one for heat necessarily. So we're pretty much done here. Now what we do still have is some high voltage circuits to work with. Now on the blower relay, your normally closed is going to control your lower speed of your fan. Now since it's normally closed, and we might add a thermostatic switch in here. Oh, wait a minute, sorry. Wrong schematic. So we added a little thermostatic switch, and now we'll go from that switch to low. Now, if you don't add the switch, call that a bonus. If you just make a line to low from normally closed, good enough. I know that you got the idea. Low is normally closed, open is high. Open is the high speed.
What type of switch you said that was?
Which one, this one?
You said thermostatic switch?
Yes.
Thermostatic.
Okay, so now we've got high and low speed energized. I'm going to now connect the run capacitor. Now, over here, you might notice that the capacitor is going to be between run and start, and that's a pretty normal thing that you're going to see continuously. But with these multi-tap motors, which run are you going to connect to? Are you going to connect to the low speed run? Is that going to work out when you're connected to the high speed tap? So what they do is, in this kit, in multi-tap motors, it wires between common and start, and works just fine. So now we need to take this back to 120 volts common. Do not take it to 24 volts common. All right, now we have our outdoor unit. The first thing we're gonna do with our outdoor unit is we have 230 volts here, and that is going to be controlled by the contactor. So we might as well energize that thing. So now our control contactor or cooling contactor is energized with 230 volts. Next thing we're going to consider is our crankcase heater. What's that crankcase heater for?
We just talked about this.
Yes, we did, sir. Yes, we did. That crankcase heater is there to prevent refrigerant from migrating under the oil of the compressor. In so doing, it needs to be on when the compressor's off. In domestic units, you'll find that the crankcase heater is directly connected to power.
I don't think I've ever paid attention to it.
It's tempting not to. It's tempting not to. In some commercial units, you're gonna find a relay or maybe a little, they got little tie-on switches to the larger contactors to where when that contactor pulls in, it can activate a switch. And so what they do is they'll put one of those on the side and make it a normally closed switch. So when the contactor pulls in, it opens it and turns the crankcase heater off while the compressor and the condenser fan are on, because it doesn't need to be on then. Next, we have our condenser fan and our compressor.
Start with the compressor.
Start with the compressor, okay. First, I'm gonna run a line for C. Take the common back. Then, I'm going to run a line for R. Oh, looky there. My polarity's reversed. Doesn't matter.
Nope. Not with contactor.
On a contactor and not with AC. It's non-polar. Some systems with computer boards in them, some of your heat pumps, some of your communicating systems, it may matter. But with the simple systems, no, it didn't matter at all. Furnaces were the first one to matter for polarity. Some furnace boards will tell you that it's reverse polarity. The really new ones now just won't even turn on if the polarity is reversed. Some of them will give you an error, like I said, but I've seen very few condensing units where it mattered. All right, so we've got more to do here. There's going to be a line that goes to the common of your dual capacitor. Now, dual capacitor is one of those, you may have picked one up in the lab or something and you've seen that there's 3 spots for a spade connector on there. So one side's gonna be maybe 5 microfarad for the condenser fan here, like from here to there is 5 microfarad, from here to there is 35 microfarad. At least that's the most popular combination. And then from there, we can just go, oop, that's the fan, I'm sorry. From there, we can just go up to start. So this capacitor is actually in between the start and run electrically. Now then, we've got our condenser fan. Let's connect our common line. And we need another run line. You'll find, the contactor can get to be a pretty crowded place. So when you're changing them out and you're, especially if you need to run to the parts house to get the right contactor, don't pull it out of there without taking a picture, making some notes, make sure you know where everything goes. Not that I don't expect that you should be able to figure it out for memorizing stuff like this, but because you want to save time. And then one more warning about contactors. Every now and then, you will come across a single pole contactor where this is just a bar across here. More than likely, if that happens, this line from the crankcase heater is gonna be up here. So watch that you don't put the crankcase heater on the other, because when you go to get a new contactor, it's going to be a double pole. You can get the single poles, but they're more expensive than the double poles because the double poles are more popular. There's a savings of money from the factory, but not at the parts house. So keep that in mind when you're going from single pole to double pole, that the crankcase heater needs to be energized all the time. So we've got one more thing to do. Connect the start to the fan's capacitor. There it is. That's everything about a basic air conditioning system.